Okay, so the topic, single replacement reactions. So pages 15, 15 and a half, 16 and 17 are the pages in your packet we're going to cover here. 15 and a half is a chart. You'll see it on page 15, but page 15 and a half has a couple of charts on it. One of which is the activity series of the metals, and another which is solubility, which you will need for double replacement, which we'll talk about soon. But basically in a single replacement reaction, one cation replaces another. Or one cation replaces another. So it kind of means what it says what it means. So what do I mean by that? It's this. Let's say it's something, A, B. The compound is made up of two things. And along comes something C. Now, this is a metal, right? It's a cation. This is a nonmetal, and we'll say that C is a metal. Well, what ends up happening is this. This metal is going to try to kick out that metal. Now, there is a hierarchy of how this occurs, and we call this the activity series. And so what you will see on page 15 of your packet is you're going to see something that looks like this. Hopefully you can see it right now. This thing right here is called the activity series of the metals. Lithium is the strongest one, all the way down to gold. Now on page 15 and a half, you're going to see just that again, but you'll just see some different elements that are otherwise there. So you can use either chart, okay? And you will be given either chart for tests and quizzes. So in this case, what you have to ask yourself is this metal stronger than this one? And so how we know that is the strongest ones are at the top. So it says most active, least active on the side. So lithium is your strongest one. So if this was lithium, it can kick out anything it wants to right there. The bottom one is gold, AU. If this was AU, there'd be nothing it could do. So let's say that this metal is stronger than this one. What ends up happening is this. You now have metal C with nonmetal B, and A is kicked out. But again, this has to be stronger than this one. Likewise, we could also do it another way. We could say, okay, well, we have, compound AB. Again, A is a metal, and B is a nonmetal, right? And along comes, I'm going to use a different letter this time, along comes D. And this thing is a nonmetal. Well, this nonmetal is going to go and kick out that nonmetal. What do we call that? We call it an anion. Because by definition, nonmetals are anions, just like metals are cations. So if this nonmetal is stronger than this one, it can kick it out. Well, you see just a few of them right here. Fluorine, chlorine, bromine, and iodine. Fluorine is the strongest, iodine is the weakest. So let's say this was fluorine trying to kick out on iodine. Then it would happen. So what ends up happening now in this case is A and D are together and B is left out. Alright, so let's do some examples of single replacement reactions. I'm on page 16 now, and I'm just doing the first one. So what we see there is we see silver plus KNO3. Well, silver is a metal, potassium is a metal. Why? Because it's positive 1 charge, nitrate is negative 1. So you have this positive 1 silver trying to replace the potassium right here. Well, what you do is you go get that periodic, or that activity series. And you look at it and you say, okay, where is silver? Well, you go find silver, it's third from the bottom. And then you go find potassium, and it's second from the top. Well, potassium, because it's higher, is stronger than silver. So you know what ends up happening? Is potassium says, no way. It's kind of like, I always think of like Biff Tannen, right? In the Back to the Future movies, if you've ever seen him, where he's, he's like, scram, get out of here, right? Well, same thing here. Potassium would tell silver, scram, get out of here. So what would happen here? No reaction, nothing. Nothing would happen. Let's look at number 2. Number 2, okay, well, that was number 1. Number 2, we have zinc now. And zinc comes along, silver nitrate, AgNO3. Well, silver is +2 charged, or sorry, zinc is plus 2 charged, silver is plus 1, minus 1, right? So zinc comes along silver. It says, you know, silver, I'd like to be paired with nitrate now. Well, if silver is stronger, it can tell it to buzz off. Well, we look at the activity series and we find zinc. And zinc is above silver. Therefore, zinc is stronger than silver. Therefore, guess what? Zinc wins. So, zinc says, all right, now I get to dance with NO3. And kicks out silver. Now, we have some problem here. When you look at your charges, zinc is always plus 2. Nitrate is minus 1. That's not the proper way to write zinc nitrate. So we have to write it correctly, right? We have to make those charges work. So we have a parentheses and a 2. We would need 2 negative 1 nitrates, right? Well, how we're going to account for that now is we're going to say, okay, we got to balance. So if you put a 2 right here, that gives you 2 NO3s. But it also gives you 2 AGs, doesn't it? So we need to put a 2 right there. Let's do one more example, number 3. Number 3 says aluminum plus H2SO4. Now you might be asking yourself, does it matter if there's more than one of them? Like this is H2 and there's only one aluminum? It doesn't matter. The aluminum is going to try to kick out the hydrogen here, right? So it says, okay, is aluminum stronger than hydrogen? Well, you go find your chart and you find that aluminum is here and hydrogen is fourth from the bottom. So aluminum is higher. Aluminum is stronger, therefore aluminum can. So what ends up happening here is aluminum, Al, ends up matched up with SO4. Now we got to make sure we wrote it right? Because aluminum is plus 3 charged, sulfate is minus 2. Uh-oh, that doesn't work. So this is Al2 parenthesis, SO4 parenthesis 3. Get rid of your charges. Plus. Hydrogen all by itself, H is kicked out. Now, hydrogen is a naturally occurring diatomic. Can't forget that. It doesn't occur as H. It occurs out in nature as H2. So now we end up asking ourselves, okay, balancing, right? So when I go to balance this, I find myself putting a 2 here initially for 2 aluminums to match 2 aluminums. But I have 3 SO4s. So I say to myself, okay, if I put a 3 right there, that gives me 3 SO4s, but that also gives me 3 times 2 for 6 hydrogens, right? So I got to put a 3 right there, and that gives me 6 hydrogens. Let's see if I can find an example where it's the anion replacing the anion. Oh, how about that? Number 4. Number 4, okay, says Cl2 comes along Ki, potassium iodide. Now some of you guys might be saying to yourself, well, Mr. Kirby, wait a minute, there's 2 chlorines here. That's just because it's a naturally occurring diatomic. But chlorine is still strong. So what ends up happening is chlorine is negatively charged, right? It carries a -1 charge. So chlorine, what it looks to do is if it can, it looks to kick out iodine. Well, we go look at the periodic or the activity series chart, and we say it says fluorine, chlorine, bromine, iodine. Chlorine is stronger than iodine. So what ends up happening is K now ends up with Cl. Now you might be saying to yourself, well, Mr. Gerber, shouldn't that be Cl2? There were 2 of them over here. But you got a problem. +1, -1, right? You got to make your charges because that's a compound. So how we'll deal with that difference is we'll balance it at the end. Plus, iodine ended up getting kicked out, right? And we can't forget that funny little thing. Let's get rid of those charges. That iodine is also a naturally occurring diatomic. Now we have to balance. So, we said we needed a 2 here to give us 2 chlorines, but that also gives us 2 potassiums. That's okay, because we'll put a 2 right there, giving us 2 potassiums, and it gives us 2 iodines to match the 2 iodines right there. And that is 1 through 4 single replacement. Again, if it can't kick it out, it's no reaction. These next ones did. I'll give you a little sneak no. Here, I will tell you. On this page, between numbers 5 and 10, so between numbers 5 and 10, there will be 3 of them where it's no reaction. Can you find the 3? There will be 3 of them between numbers 5 and